In this video, we're going to talk about NeoPixels. Now, NeoPixels are a special type of LED with an integrated driver chip. So this chip inside of there allows you to a lot more easily control the color of the LED. So previously we've used like RGB LEDs where we are able to, with like individual pins from the Arduino, individually control and drive how much red, green, or blue are present. In the NeoPixel realm, what we're going to be able to do is control the color just with one single pin. That one single pin is sending data to each of the integrated chips within the individual NeoPixels to control the color of them. And so NeoPixels come in a variety of different like form factors. So there's like these strips here. Yeah, there's a ton of different strips. But if we keep scrolling down, you can see there's like rings. There are individual like ones that you can buy, but there's also these like LED matrices, and some of them are like flexible and stuff like that. And yeah, here are like the more individual ones that you can wire up. They also come in like through-hole parts that you can solder onto a board. There's a variety of different things that you can do with them, but all the control mechanisms in the code are the same. They're made to work very well together so that I can just chain them all together, kind of similar to how they're used here in this big long strip. I can just add a bunch of them together and send that one wire through all of them to be able to control the color of them. So over here I have my Arduino set up controlling this strand of 30 NeoPixels, and it's just kind of telling it the different colors that it wants it to do. And I promise the colors are a lot more brighter and more vivid. In real life, the camera kind of washes out the colors a little bit. I tried to dim it as much as I could and have it reflecting off this white paper. But you can see it's just dialing in all of these different things, and it's only doing that with these three wires. So this is my 5-volt and ground over here, and then this is just the data pin that's wired up to pin 6. So this is the one wire that's controlling everything here. So let's flip over to this view here. So yeah, for the hardware, all that you need is some 5-volt connection, some ground connection, and some data connection. Now, if you're going to be powering a lot of different NeoPixels kind of at their full brightness over a long period of time and have multiple of them on at a time, you're not going to want to power it from the Arduino like I have. Like I'm doing right now. What I've done is I've set the brightness pretty low to make sure that I'm not going to damage the Arduino by pulling too much power from it to power all the individual LEDs. If you are going to power a lot of LEDs, what you're going to need to do is wire it to an external power supply, but you'll still want to connect the ground and the data pin to your Arduino. So on each individual NeoPixel, what there will be is a data in pin and a data out. And so what that data in is the information coming in from the Arduino, and the data out is going to be the one that hops over to the next NeoPixel, and then the next NeoPixel, and the next NeoPixel. So you would connect the data out of one NeoPixel to the data in of the next NeoPixel, and so on down the line to kind of continue to pass along that information there. So in order to write some code, the first step that we're going to need to do is install the NeoPixel library from Adafruit. Adafruit are the people that make these, and they're not the only people that make something like this, but they are, you know, a really good company that makes some really great stuff. You can search online for WS2812. That's kind of the name of the chip or the protocol that's used to communicate and control this. So you can look for anything that is compatible with this, and it should work with this NeoPixel library, but I think it's like the easiest to work with. So what you're going to need to do is pull up your Arduino, and if you hit this little icon over here that looks like books, this is where the libraries are stored. And so what a library is just some code that is written that we can then leverage, and we're eventually going to use the NeoPixel functions that Adafruit wrote for us. So what I need to do is find it and install it. So I'll come over here and I'll write Adafruit NeoPixel, and I've already installed it. So you can see right here it says remove, but if I hadn't, this would say install, and I would click that, and then I'm able to include the NeoPixel library into my project. So that's the first step, is install it, and you only have to do that once and then you're good to go. And so once I've done that, now what I can do is I can include the NeoPixel library. So that's going to be the first part in any project that relies on NeoPixels, is just including that library. So that's what that line of code would look like. Next, what I need to do is define which pin the data pin is connected to on the NeoPixels. So here I've connected it to pin 6 on my Arduino, so I would just write LED underscore pin as 6. And then what I need to do is define how many NeoPixels are chained together that are attached to that pin. So on my strand, I have 30 NeoPixels on this one strand, and so I would just say LED count 30. So the next step, and this kind of looks like a big mess here, but what we're doing is we're creating the NeoPixel strip object with which we can call these different functions or methods on to control it. And so what it would be is it's declaring a variable called strip. The type of that variable is Adafruit NeoPixel, and I'm setting it equal to this call right here, which creates that strip object. So I'm saying Adafruit underscore NeoPixel, and then it expects 3 arguments. The first argument is the number of NeoPixels, so I would just pass in this macro here that I pound defined as LED count to represent the value 30. And then the second argument is the Arduino pin number, right? So what I would do here is just pass in LED underscore pin, which is the macro that is alias to the number 6. And then the last one here is this argument 3, which defines the type of pixel that you have. For most instances, it is just going to be this. It's going to be neo underscore grb plus neo underscore khz kilohertz 800. That's typically what it's going to be. If you are running into issues with it, you can try some of these other ones here to see how it works out. But for most times, it's just going to be this, unless you have an older style. And that's what we need to do kind of outside of the functions. It's just kind of those 4 lines of code, right? So we're just including the library, defining the pin number, defining the number of LEDs, and defining the strip here. Then what we need to do is, in order to control the NeoPixel, what we're going to do is there's a few setup steps that we need to put inside of our setup function. So the first is we say strip.begin, which initializes it and allows us to be able to control our NeoPixel object. So this is a required step. Then we call strip.show. And so what strip.show does is that updates whatever changes we make, whether we're like turning on or off individual pixels. And so we should just call strip.show at the beginning just to make sure that everything starts in this off state. And then the last step we need to do is set the brightness. And so this is not meant to be changed throughout the program. Like if you want your pixel to be brighter or dimmer, what you would actually do is change the color values, not the brightness values. So this is only meant to be done once inside of setup, and it takes some value between 0 and 255. But the note here that I said, and this is what I mentioned earlier, is since I'm powering it from my Arduino, I need to keep this brightness value very low to prevent it from damaging my Arduino, since it can't provide a ton of power. But what you could do is, connect it out to some different, what's called like a wall wart or an AC to DC adapter that provides 5 volts at a higher current level, so that you can, turn all your NeoPixels on at maximum brightness and not worry about damaging any of the components. But right now I'm doing 10 and it looks fine. So those are kind of all the basic steps that you would do basically in every project that uses NeoPixels. You would define this stuff and set it up like this. Then what you're going to do is inside of your loop, this is where you're going to add the code to actually control it based on whatever it is you want to do. So I'm going to flip back over to here so we can take a look at some of my examples, but basically I just kind of walk through a lot of that stuff here. But this is the very basics in how you can control it, right? So the first function that's kind of the most helpful here is this strip.setPixelColor. And so that takes 4 arguments, 4 input values, to be able to control the individual colors of the NeoPixels. And so the first value here is this value n, which is an integer value that represents which NeoPixel we want to represent. So in my case, there are 30 NeoPixels, and you might think that the first NeoPixel would be 1, the last one would be 30, but in programming parlance, like we always start counting at 0 in programming. 0 is the first value, so the first NeoPixel would be the value 0, and the last one would be 29. So it might take a little bit of getting used to, but we've already kind of set up some stuff like that before, like for our for loops. So hopefully you're starting to get used to that. But yeah, the first value is 0, the last value is, in this case, 29. And then what I do is I provide 3 other values, which are the intensity of the red, green, and blue colors. So if you understand digital color, what it is just a combination of adding together red, green, and blue. It's an additive color wheel where if I add equal parts red and blue, I get magenta. If I add equal parts red and green, I get yellow. And if I add, green and blue, I get cyan. And then if I add all three in the equal maximum parts, I get white. And so digital color is typically represented with 8 bits. That's 8 binary digits, 8 zeros and ones. And so the maximum value we can represent with 8 bits is 255. So that's why these values here are some color value between 0 and 255. That's kind of what that represents. Sometimes you might also see things provided as like a hexadecimal number, and those actually map the same way. So here, this is just true red, so the maximum value of red at 255, and then green and blue are 0 and 0. This maps directly onto this hexadecimal code where the first 2 hexadecimal digits represent the red, the next 2 represent the green, and the next 2 represent the blue. And we could talk about this more at another point, but I just kind of wanted you to understand that. And then playing around with a color picker like this can be helpful to kind of understand, how these colors mix together and things like that. So this is just the one provided from W3 Schools, but there's so many different color pickers where you can find, the RGB required to make some specific color, and then you can make your NeoPixel that color. All right, so that's kind of the most important one here is this set pixel color. But the one step that's pretty often forgot is once you've set the pixel color, you're not going to actually see it on your NeoPixel yet. What you need to do is you need to call strip.show, and that is what pushes that information to the NeoPixel to actually have it show that new color. And so the reason it's done like that is maybe you want to do like some animation on one of those matrices, right? So you would have to set each of the individual pixels for like the next frame of the animation, and then you would want to show the update and reflect like all of the pixels updating at once. So that's why this strip.show is helpful. But yeah, so you'll set the individual colors with strip.setPixelColor, where you say what value or which pixel you want starting at 0 going up to however many different NeoPixels there are. Then you specify the red, green, and blue components, and then you would call strip.show. Finally, there's like a couple other helpful functions here, strip.clear and strip.numpixels. So strip.clear just tells you, or it just clears out all of them and turns them off. The strip.numpixels would just tell you how many pixels you define for that strip, which would just be the same as this LED count, right? It should just tell me 30. So let's go through and implement something here to control this. So what I'm going to do is I'm actually going to define a couple of global variables. So what I'm going to do is my first one is going to represent what pixel number I'm on, and I'm going to start it at 0 because remember our first NeoPixel is going to be number 0. And then what I'm going to do is I'm going to declare some variables for like the color that I want to set. And so I could say red, or let's just make it really short, R, G, and B. And so yeah, let's do this. We'll do like maximum red, no green, and like half blue, and we'll kind of see what that looks like here. Okay, so what I need to do is I'm going to try to one by one update each one of the pixels to be this color here. And so what that looks like is inside of here, that would be a call to strip.setPixelColor, and the first value it wants is what number pixel I'm talking about, so that would be number pixel. And then it's the red value followed by the green, red, green, blue, like that. But this would only update the first one, and it would just set it to be that one color and kind of keep going on and on, right? So we've talked about how to do this by updating these global variables or using a for loop. So right now we're going to start with updating these global variables. So what I'm going to do is it's going to set the first value, and then I'm going to add 1 to this value by saying numpixel++, which would increase it from 0 to 1, then 1 to 2, then 3 to 4, and so on. And then what I need to do is once I get to the end, I need to set it back to 0. And so what I'm going to do here is I'm going to say if number of pixel is equal to strip dot let's see, number of pixels, which will return to me 30. So I'm going to say if I get to this value and number of pixel equals 30, because remember, there's not one that is actual number 30. The last one is number 29 because we start counting at 0. So we're saying if it's equal to 30, what we should do is we should set numpixel back down to 0. Okay, and then what I'm going to do as a last step here is I'm going to set a bit of a delay between each one of these updates so it doesn't just race down the line. There's like some delay between it setting each of the different values. And we're going to upload this program and see what happens here. So let me go back over to here. And okay, they're off, and nothing's happening. So why is that? So I'll look back here, and the reason for that is I forgot the one step that I said is common to forget. And that is doing strip.show, because this sets the color, but it's not actually reflected until I call strip.show. So now we're going to upload it with that new strip.show, and hopefully we should see it do that color kind of racing down the line there. So this is my pixel 0 is on the outside, and it kind of spirals into the end, and it's showing this nice pink color because it's like full intensity red and a little bit of blue. So that's what we have here. So I could hit the reset button here to start from the beginning, so they should all be off, and then it goes around to the beginning. So that's how that works. If we wanted to, make it a little bit more interesting and have it change colors over time, what we could do is we could change the R, G, and B global variables here, because they're hard-coded to be this, and they never change again. And so we could use the random function. What the random function does is it will generate some random value between two bounds. And so what we could do is to just have it randomly choose a red, green, and blue. So if I say random, the first value I say is where I want it to start choosing a value from, and then the last one is the upper bound, but it does not include this upper bound. So it's inclusive of this first number, but exclusive of the second number. So this would make it choose some random value between 0 and 255, which is our valid color values. So I'm going to copy and paste this here for the green and the blue, so that each time it's choosing a random red, green, and blue value. So it would choose that at the start, but then it would just continue to write those same values. So if I want to update this, what I would do is I would copy this and maybe say once it gets to the end, right, when numpixel equals the total number of pixels, and we set it back to 0 to go back to the beginning, let's update those values. So I'm going to paste this here, and then I also have to remember to remove this int, because what that would try to do is declare a new variable called R, but one of those already exists. It exists up here and is a global variable. So what it should do is set all of them to be the initial random color, and then once it gets to the end, it's going to go back around, choose a new color, and set all of them to that new color. So let's upload here and go to the camera, and so it's uploading, and hopefully it'll go black, and our first color is kind of a bluish white. That one's a little bit more blue, and we get yellow. So that is working the way that we want. And again, it's a little more washed out here on the camera than it is in real life, so hopefully if you're playing around with this on your end, you're pretty impressed with the colors. But that is kind of the basics of working with a NeoPixel. Again, it's just a really nice way of being able to control the color of, in this case, a bunch of different LEDs with just a single wire and then our power and ground connections. As opposed to, like, if you could imagine, if we were trying to control 30 RGB LEDs without any sort of driver chip, any sort of smarts for it, right? We would need 3 pins on the Arduino for every single LED, and so 3 times 30, we're quickly running out of pins here, right? So NeoPixels are a really great way to incorporate color and light into any project of yours.